Hi everyone, welcome to another video on cubic functions. Now in the previous video we introduced the idea of a cubic function. We even drew a nice big picture of it to see what happens for different values of x and how this affects the y. In this video we are going to take my basic graph of a cubic function, my y equals x cubed, and in the same way we did for something like a parabola, we're going to apply two different transformations to it in this video and look at how this changes the actual cubic function. Now, two of these examples we're going to go through today. Now, the first one is the graph of y equals to 2x cubed, and the second one is going to be y equals negative a half x cubed. Now we are going to do a table of values for both of these just to start us off, and we're going to see how these different things, these elements, this thing here and this thing here, affect my cubic function. Now let's draw up a table of values for this first one. X, y. Let's go from just -2 up to +2. Okay, so substituting in -2 in place of the x, this gives me -2 cubed, which gives me 8. But then remember, we have to multiply by this 2 in front of it. So this gives me 2 times 8, that gives me 16. -1 cubed gives me 1, timesing that by 2 gives me 2. 0 is just going to give me 0. Oh, sorry, we have negatives here, my bad, because -2 cubed gives me -8, times by 2 gives me -16. -1 cubed gives me -1, times 2 gives me -2, and then these ones are going to be positive here. So let's just draw that in. When x is -2, y is -16. So x is -2, y is down about here. When x is -1, y is -2. So that's about here. I get 0, and I get this thing up here, and I get this here. Now, if I connect the dots like I've done before, you will notice that I get a slightly steeper graph. Because not only is cubing the x getting applied, but once I've cubed this, I'm going to multiply that by 2. So the y's are going to grow at a much faster rate. Normally here, I would have had the coordinate, let's color code this, I would have had the coordinate of 2 and 8 here, or -2, -8. But now I have scaled this up by 2. So the -8 becomes -16. Hence the graph is going to get a lot steeper in order to reach this point in time. And the same thing is going to happen here. I have 2 and 16. So the result is I get a much steeper graph. Now this next one over here, I have a negative in front. Now some of you may be clued onto this by now from the other transformation videos, but that's going to do something really special to the graph. We're going to investigate that now. But we're doing the same kind of thing, and we're trying to find the value of y for these different values of x. Now substituting x equals -2 in place of the x cubed, that will give me 8 times by negative a half. So minus 2 cubed gives me 8. Sorry, gives me negative 8. Timesing that by negative a half gives me positive 4. Doing that for the next one, negative 1 cubed gives me negative 1. Timesing that by negative a half gives me positive a half. 0 gives me 0. Now when I substitute in 1 for the x, 1 cubed is going to be 1. Times by negative a half gives me negative a half. And 2 cubed gives me 8. Times that by negative a half gives me negative 4. So let's draw this one now and see what happens here. So when x is negative 2, y is negative 4. So that's about like here-ish. Obviously this isn't to scale. I'm just trying to draw this relative to where I did my other points. When x is negative 1, we get negative a half. For 0, we get 0, and we get a half here. And for 2, when x is 2, oh, that's not true. I'm doing this wrong. When x is negative 2, y is 4. So that's going to be about up here. When x is negative 1, y is a half. That's about down here. 0, 0. When x is 1, y is negative a half. So that's about here. And when x is 2, y is negative 4. So that's about down here. So if I connect these dots, you can see I get a slightly wider, less steep looking curve here. This is my curve of, whoops, this is my curve of y equals negative a half x cubed. And looking at the points, they are once again scaled by a half, because here my negative 2, my y coordinate is 4, and it's not only scaled by half, not only do I go from 8 to 4, but it's scaled by negative a half. So my negative points on my original cubic, this thing here, becomes positive. Now why is that? Well, our old friend, the reflection, has reappeared. So the negative in front, that always ends up being some kind of vertical reflection. So everything down here that's below the x-axis goes above the x-axis. Everything that was previously above the x-axis now goes below the x-axis. I am transforming this by flipping it, by reflecting it in the vertical direction. And I can see that all my points here are getting, my y coordinates are getting transformed, multiplied by a factor of negative a half. Here my 8 goes to negative 4. So half of 8 is 4, negative half of 8 is negative 4. So this is how these two transformations can affect my graph. So when I have some kind of coefficient, a positive coefficient that gets bigger than 1, like this 2 for example, my graph gets steeper. If I have a coefficient like a half, which is less than 1, it's going to get narrower, a bit wider. And the negative here ends up being a reflection. So my graph will get vertically reflected. Where it was once positive values of y, it becomes negative values for y. Where it was once negative values of y, we get now positive values of y. So these transformations work in the exact same way as they did for parabolas, for exponentials, for hyperbolas. They're all doing the same thing. Hopefully we're noticing a pattern here when we apply these types of transformations. This is how we can start to think about transforming our cubic functions.